Okay, where do you put the tick marks for the slope field? Only the places where there are dots. So if you put in this ordered pair 1, comma 1, I'm going to substitute that right in here for the slope. So dy dx, you don't have to show this work, is equal to 1 plus 1 over 1. So what's the slope there? It's 2. No, just your little lines. So what if I do 1, 0? So dy dx, and you can do it in your head, is equal to 1 plus 0 over 1. So it's 1. What happens when y is negative 1, no matter what x is? Except for 0. Shouldn't say that. This is 0, so this is 0. But notice there are no tick marks on the, no dots on the axis. Because if you're talking about the y-axis, x is 0 there, and you can't divide by 0. Negative 1 is 1 minus 1 over 1, so it's okay. How about at negative 1, 0? The y is 0, x is negative 1, so this is negative 1. What do you think this one is? When y is 1, that becomes 2 in the numerator. It's negative 2. One more dot. Oh, two more dots. How about negative 2, 0, 2, 0? So at 2, 0, I've got 1 plus 0 over 2. So it's 1 half. How about negative 2? And it's 1 plus 0 over negative 2. Negative 1 half. That's all you have to do. All this work here I wrote is not worth anything. They're not. Because I have both x's and y's in them. If it's only x's, then it looks one way. If it's only y's, it looks another. And I have to do it because I always forget which way. Could be. I won't even go there. That's it. 2 points. Yeah, we're going to do B. It says the sign of each slope, so positive and negative, and relative steepness, so that this is less steep. Yeah, I don't think I graded one of those, so I don't know how particular they are with that. This is free response. Where's your green sheet? I don't have one. You should have one. Did my last one go? Okay, these are old. You got these last week, so you probably have it. Okay, so let's find dy dx. Let's do our differential equation. This one's kind of a tough one, actually, to finish solving correctly. dy dx equals 1 plus y over x. Okay, do I need to write the steps down again? First thing, separate the variables. Cannot have mixed variables. No mixed vegetables. They got to be separated. Okay, so I'm going to multiply through by dx. So it's 1 plus y over x dx. And you always undo by multiplying or dividing. This is what I don't want there. Can't have mixed variables. Okay, so I'll divide by what? 1 plus y. Okay, so we are going to have dy over 1 plus y on the left equals dx over x. I'm going to write it the way you're probably going to write it. And then we're going to do what with that? What's the next step? We did that. We separated the variables, and then we integrate. Okay. Well, if I wrote this way, maybe you'll see it better. So what function is it? It's a natural log. If I had 1 plus y squared, you couldn't do it. So it's the natural log of absolute value of 1 plus y equals the natural log of the absolute value of x plus c. Is that okay, Declan? Yeah. It won't. You have to always have these differentials in the numerator. You always multiply 3 by dx because you're always given dy dx. Everything has to look like that bottom of that derivative integral worksheet. Everything does. So if it doesn't, then you have to do a u substitution to make it look like it. Okay, so what are we going to do? We're going to add c, right? We got 3 points now. How do you get the 4th point? No, no, no. Put in the particular solution. Use the initial conditions. No, that's negative 1, 1. This is like solving for b in y equals mx plus b. It's exactly the same. So in place of y, you're going to put 1. So this is the natural log of 1 plus 1 equals the natural log of the absolute value of negative 1 plus c. I now have values. So I can solve for c. It's exactly like y equals mx plus b. This is the log of 2 equals the log of what? 1. What is the log of 1? That's 0. So c is equal to the natural log of 2. So I'm going to put that back into my function equation. And it gets a little tricky to do the rest of this problem. So I'm going to have the natural log of the absolute value of 1 plus y is equal to the natural log of the absolute value of x plus the natural log of 2. Yeah, that's the hard part. How do we solve for y? I think I have 4, maybe 5. So it's e plus the first 2. So we did pretty well. The domain question's hard. It's e to the entire side. It does not equal e to the log of absolute value of x plus e to the log of 2. It never will be. It will never be that. You can't ever bring that down. So once I see that, I'm done. I've stopped reading because it's wrong. Okay, so I'm going to get on the left side the absolute value of 1 plus y equals e to the natural log of the absolute value of x plus the natural log of 2. When in doubt, just leave it alone. Do we know what it is, though? Careful. It's the e's close with the 2x. It's this times e to the natural log of 2. Not plus, it's times. Using rules for exponents. What? This is the absolute value of x, not x. Well, it was close. Times 2. So I have the absolute value of 1 plus y is equal to the absolute value of 2x. No, because we have to solve for y. Well, this side's not a problem. How do you do this? You can put in 2 times the absolute value of x in here. So 1 plus y is equal to the absolute value of x times 2, or 2 absolute value of x. Or 1 plus y equals the opposite of this. What? What's the question? Because it's e to the log of absolute value of x. E and log cancel out, so it's just absolute value of x. And this is e to the log of 2, it's just that. You could leave it like here, too, by the way. So y equals 2 times the absolute value of x minus 1, or y equals minus 2 absolute value of x minus 1. Only one of those is going to work. Well, I know it went through negative 1, 1. So if I substitute negative 1, 1 into both equations, only one's going to work. So let's put it into this one. Y is 1, 2 absolute value of negative 1 minus 1. Did I do that right? So that's 2 minus 1. 1 is equal to 1. This one is the solution. The other one will give me a negative 3 or something. Then you have to figure out the domain. This is hard. if I get it right. It says, and state the domain. What's the problem? X can't be 0. No. Okay, X can't be 0, but you only get one of these solutions. You get this one. No, here's what you should do, is just cross that out. If you start, there's a vertical asymptote here. So if you start at negative 1, 1, which is right here, this is pointing you this way. And I believe that X must be less than 0. You can't cross that. So your domain is, actually should have been a straight line, but X is less than 0. Let's see if I'm right. That's hard. That's only 1 point. Okay, let's see what we got. We have 1 point for separating. Oh, they gave us 1 point for each antiderivative. That's very nice. 1 point for your C. 1 point for using the initial condition, even if I did it wrong. Notice C, if you don't separate the variables, 0 out of 6. And then the domain. Pardon? Yeah. If you have X's and Y's on the same side, you have mixed vegetables. We don't want mixed vegetables. Does that work? Because there's a vertical asymptote here. That's why it's hard. Sorry, I should make it a line because I know it looks like this. You can't put in a positive one, can't cross this because X can't be 0. So how are you going to get over there? This other equation is the other side. The other equation is the other side. So it's only one side. That's really tough. I think I probably got it wrong. I probably think I said X is just not 0. That would be wrong. But that's only 1 point. So, yeah, we still have 8 if we did all the rest correctly. You could have left, by the way, your answer, you could have left this like this. On this right side, you didn't have to make it the opposite of X times 2. What? Correct. 6. 6. No. You have to do all 6. Right. You get 1 here. Actually, we're not going to lose that many. But, yeah, you'll lose 3 here. Right. Not eligible for the answer point. Well, it doesn't make sense. So don't come in and put the C later. Some people will come in and say, oh, we're supposed to have a C there. No, no, no. Sometimes it works. Most of the time it doesn't. Yep, just cross it out. Okay. Do you want to do the other side? Yeah. Well, I have to. That's what I'm doing. I'd like to go through the pink packet. And once you've seen one of these, you've seen them all. It is true. How do you know what? I'm sorry, you can't hear you. What? The domain, it goes through negative 2, 1. I can't get over to the other side. Here's the answer here. I would leave it like that than trying to do that. X can't ever be 0. So when I come down here at this value, I have to what? I have to stop. I can't get across the wall because X can't be 0. It's hard. Yeah, it's still a function. It's not continuous. I mean, include what? Because X can't be 0, you can't get across that. That's the problem. Okay, we ready? Let's look at the pink one. Help me out and tell me where we're at. I have a few extras. I'm going to collect the pink one and the yellow one tomorrow. My focus on the yellow one is the first three. I did the first three. They should be done. So help me out. Tell me which ones you need. Like I said, I'm not too worried about it. I'm sorry, what? Yes. I think we did through number 6, didn't we? We skipped 4. Nobody seems to want to do that. So let's look at number 4. This is a rumor. The total number of people is n. Pink. And it says the rumor spreads at a rate proportional to the product of the number of people who hear the rumor and the number of people who have not. So P is equal to the number who hear. Four. Pink. Okay, if there's n people altogether, and P represents how many who heard the rumor, how many did not hear the rumor? Yeah, how do you express it with n and p? N minus p. Total number of people altogether minus those who hear. Either you heard it or you didn't hear it. And it says the population is proportional to that. So it's equal to k, n minus p. And there's an answer that matches that. B. Oh, excuse me. No, I didn't read it correctly. It's the product of the people who hear and the people who don't hear. So it's this one, which is B. I got the right answer, but in the wrong reason. Okay, so A is not right because they don't have that product. C has a product, but the n minus p is in the wrong order. D has a t there instead of the population, and same with E. Because it's proportional to the product of the population. Product is multiplied. No, product is the number of people who heard the rumor, which is P, times those who don't, n minus P. That was it. This is kind of one of those that could be on the exam. Both. The AP exam. That's why I give you exam questions. 22, then we're going to jump back. And if you try a U substitution, it doesn't work. It says the product of the number of people who hear, which is P, times the number who don't hear, which is n minus P. In the reading. Okay, you guys ready for this? Okay, you guys ready? What does this bar mean? The bar means divide. So this is the same as this. I can divide both elements in the numerator by x. Is that okay? Because you can't do a U substitution. It's not going to work. I always divide if I can. If you let u equals x squared minus 1, then du is equal to 2x dx. I have x dx. I don't have x dx. I have 1 over x dx. No, it's not the same thing. Sure. So it's 1/2, then it's u, and then you have an x. I don't even know what you got. It doesn't work. Because the x is in the wrong place. if the x had been here, it would have worked fine. We'll just divide it up. It's division. X squared over x minus 1 over x. Let's bring that up. Oh, hang on. That's right. X minus 1 over x. That's why you need to do the homework, because you know what? There are only so many integrals that can be done. It can be done. So it's x squared over 2 minus the natural log. I would put absolute value in, but I don't have to because these numbers are positive. From 1. Right. What? Ln, what is the ln of e? Yeah, L. Yes, and guess what? You get the same answer. You'll distribute that, and you'll get that. Which, that's easier, unfortunately. I could. It's not certainly not wrong. So it's e squared over 2 minus the natural log of e. Or absolute value of e, doesn't matter. And it's minus, and then you put in the 1. 1/2 minus the log of 1. What's the log of e? That's 1. What's log of 1? 0. Yeah, what? So it's e squared over 2 minus 1 minus 1/2. Or e squared over 2 minus 3/2. Where'd I get what? Question? Yeah, just simplify it. Okay, do you want to jump back now and go do things in order? I don't really care, but most of you people like to do things in order. In the back. You know how they went out. Oh, there's some there. Never mind. Nobody asked me about 7. I'm going to get rid of the function there. If the function doesn't look like anything on my list, it has to be exactly like what's on my list of those ones we can integrate, then you have to do a U substitution. Or something like we did, we divided. Yeah. Practice is how you'll know. Yeah. You'd have to get nice size of the angles. That's what you'd have to do. Okay, let's do this. Now, you guys, this is the area. Let's do this visually. This is the area from, I don't know where this is. This is -5 to 2. That's what the first integral is. That's -17. Okay, not obviously drawn to scale. Supposed to be negative. But what's wrong with this area? That's going from 2 to 5. That's the wrong, 5 to 2. That's the wrong order, isn't it? It's the very top of the page. That's number 7. So I can change this to do this. I can make it 2 to 5. That's equal to +4. We're doing number 7. This is the area from -5 to 2. This is in the wrong order. It's from 5 to 2. I want it from 2 to 5. So then from 2 to 5, that's a +4. So it's -17 plus 4, or -13. My picture's wrong. So it's B. Guys, what? Because this is in the wrong order. Because if I want the integral from -5 to 5, I have to do the integral from -5 to 2 plus 2 to 5. -17. Well, they told me that. My picture's not right. My picture's not correct. I should have drawn something like this. Yeah, but the idea is, this is the idea. No, that's the idea. You've got to have these go in the right order. Doesn't matter what the sign is. How about number 8? Number 9 is graphing calculator problem. 10. Okay, let's go back and do 8, then we'll do 10. Number 8, minute they tell me this, I think I'm going to do the fundamental theorem. No, they did not give me very much here. G is the antiderivative of f of x. Okay, guys? This is used all the time. So let's get this nailed down. When you are given one ordered pair, they're going to have you do the fundamental theorem of calculus. We're going to integrate from 2 to 4. So that's equal to the antiderivative of f, which they said was g. And you're going to evaluate it at 2 and 4. So this is equal to g of 4 minus g of 2. That's the fundamental theorem of calculus right here. That if you see an integral with limits on it, you just find the antiderivative and evaluate it at 4 and 2. So solving for g of 4 here, g of 4 is equal to g of 2 plus the integral from 2 to 4 of f of x dx. And what's g of 2? -7. Then you look through your answers. I don't have a number here because I don't know what f of x is. So which one matches that? It's E, because 7 is not in the integral, -7. I want g of 4. Use the fundamental theorem of calculus. So that is E. Can't be D because the -7 is an integral. That's already been done. C doesn't have anything with it. B is -7 plus the derivative of f, which makes no sense. And A is the derivative of f, which makes no sense again. But you have an integral in your answer. That's the fundamental theorem. We'll do another one, I'm sure. How about 10? I want the average value of a function. Do you remember how to do that? You integrate the function divided by the width of the interval. So I'm going to integrate this one. And looking at the answers, I would say that this is a calculator problem. Make sure you are in radian mode. And you divide by what? The width of the interval, which is how many spaces? 4. So it's 1/4. And then I can't integrate that. I have to use my calculator. And it is. It gives you the average value. Average value is the integral divided by the width. How about number 11? You guys get number 11? How about number 11? Did you guys get number 11? Sure. You guys. Number 11, I want to integrate from 0 to 1 of e to the minus 4x dx. Guess what? That does not look like e to the x. That was 10. I have to use my calculator. I'm too lazy. Don't forget to divide by the 4, though. Okay, this does not look like e to the x. I have to make it look like e to the x. There's a composite function there. It's e, and that's linear. So I'm going to let u equal negative 4x. Then what's du? What's du? Negative 4 dx. Solving for dx, we'll divide by negative 4. So the dx here is going to be negative 1/4 du. This is going to be u. So I'm going to get, and I'm going to switch those limits of integration, e to du with a negative 1/4 out in front. Is that okay? Up this one? That's a different problem. 3 minus a minus 1. This negative 4 was the derivative. Okay, let's switch over the u's too. Because if x is 0, what's u equal to? Negative 4 times 0 is 0. If x is equal to 1, then u is negative 4 times 1, which is negative 4. So we're going to integrate on the u's from 0 to negative 4. Now, I don't have to go back to the x's. I don't want to. So it's negative 1/4 e to the negative 4 minus, what? Because these are the u's. These are u's. You have to, not can. These are x coordinates. I have to do the shift over to the u's. And then it's going to be minus a negative 1/4 e to the 0. So that's negative 1/4 e to the negative 4 plus 1/4. How is that written for an answer? Yep, it's D. Yeah, that's not good. What about third sheet? You tell me. All of these are fair game. Which one? You want to do 14? Yes, you do. I could go back to x's, because this is going to be negative 1/4 e to the u, which is negative 1/4 e to the minus 4x. Let's do it. No, no, if I change it back, then it's going to be negative 1/4 e to the u is what I have. So it's negative 1/4 e to the negative 4x. Then we have to use the x values, which were 0 and 1. So if you do that, that's e to the negative 4 minus or plus 1/4 e to the 0. It's the same thing. Declan, it's the same thing. I use a u substitution when I don't have e to the x. It has to be one of those finite number ones, you know, the integral of sine, integral of cosine. You want to make it look like one of those because you can integrate those. You have to be able to match it, so I'm not sure I answer your question. You have to be able to match it. So I'm not sure I know what your question is. You guys keep talking about domain, and we're not talking about domain. No, but we better do number 14 because now you have no choice. Casey. Casey? Yes. Yes, so you're doing 14. So let's look at 14. And they tell us the u substitution. It's the integral from 0 to 2, the square root of 2x plus 1 dx. And they said let u equal 2x plus 1. And if you look at the answers, everything's in terms of u. So we must. You're not integrating this, but you must change it over. So it's the integral of the square root of u du. That's the easy part. And now, if x equals 0, what's u equal to? Because 2 times 0 plus 1 is 1. Okay, oh, I forgot to do my du too, by the way. Well, let's finish the limits. There's no c. If x is equal to 2, what's u equal to? 2 times 2 plus 1. So that's what? 5. And then I forgot to do my du. If u is equal to 2x plus 1, what's du? What's the derivative of 2x? It's 2. So solving for dx, that's equal to 1/2 of du. So what needs to be out in front here yet? What needs to be out here? A 1/2. Because dx equals 1/2 of du. That's it. They didn't ask us to integrate it. They said which ones could be. If you look at your answers, A doesn't have the right limits. If they ask you a question like this, yes. But you don't have to. You can go back to the x's. You're gonna evaluate the u originally or later. It's the same. You're gonna have to do it one way or the other. So let's see. I've got to go 1 to 5. So the answer is C. Yes, if you don't know what is going to happen, yes. After you've integrated, I could have done that, but that's not this question. Max, I'll do it. Yeah. How about number 15? How about 15? Okay, guys. Did you try 15? Sorry, it's the best I can do with cut and paste. It says the rate of change of the volume, that's dV dt. Okay, so dV dt is directly proportional to the square root of the volume. D. And that's the one that's going to, it came through the rumor problem, all this same. Sixteen's a good one. 16 says a curve has a slope 2x plus 3. Now, it didn't say it was a line. So this is dy dx is equal to 2x plus 3. And it's going to go through the point 1, 2. So it's a differential equation, so guess what we do? Solve for dy. So dy equals 2x plus 3 times dx. And then you do what? Integrate. So what's the left side? 1 what? Y. What's the integral of 2x? Because what's the antiderivative of 1 with respect to y? Plus 3x plus c. So all we have to do is find c. But I know what some values are. Y is 2 equals 1 squared plus 3 times 1 plus c. So c equals, oops, I skipped stuff. Because I just substituted it in. This is the antiderivative of 2x plus 3, and then you put in the 1, 2. So that gives me 4. I'm going to wait. Gives me 2 equals 4 plus c. So c is negative 2. You have some multiple choice, some just plain problems to do with these substitutions. Well, those are not AP questions, but they could be. So you have some multiple choice. Let's do the triangle one. Because it doesn't have a number, for one. So it's between 16 and 17. And I think I heard somebody say the right thing. That's right. When they give you f of 0 is equal to 5, and they ask you to find f of 1, and you're given the derivative, it seems to me I'm going to use the fundamental theorem of calculus. Because if I integrate f prime of x, and I'm going to integrate from 0 to 1, what's the antiderivative of f prime? What's the antiderivative of f prime? It's just f. So it's f of x between 0 and 1. So that's equal to f of 1 minus f of 0. So I want to find f of 1. So f of 1 is equal to f of 0 plus this integral. 5 plus whatever you get. But this is easy. Do you have to integrate this, or could you just find the area under the curve? I believe so. This is 1/2. 1 times 6, or 3. So it's 5. Whoopsie. Sorry, it's 5 plus 3. So the answer is 8, which is D. This is the area of the triangle. The one after it, which is problem 17, is the second fundamental theorem of calculus. It's the derivative of the antiderivative. Yes, but be careful, it's composite. So you're going to put this in here. The derivative undoes the antiderivative. They cancel each other out. So you still have the sine function, but it's the sine of x squared cubed. And then because if you had integrated it, you would have some function of x squared. You have to differentiate that x squared, so you have to multiply by the chain rule. 2x. So the answer is E. Because if I were to actually integrate this, I'd have some function of x squared, and I have to do the derivative, chain rule. 18? 18 says, a particle moves along the x-axis. The acceleration, a, is equal to the natural log of 1 plus 2 to the t. And I want to find the velocity. I know that v of 1 is 2. I want to find v of 2. Yep, we're going to find the antiderivative of the acceleration. But I don't know how to integrate that. So I'm going to use my calculator. I'm going to integrate a from 1 to 2. And what's that going to give me? What's the antiderivative of the acceleration? Hey guys, exactly. Antiderivative of acceleration is the velocity. So it's going to be v of 2 minus v of 1. Guess what? Can't I integrate this on my calculator? Can't you find the you can't find the antiderivative, but can't you find the definite integral? Sure. Equals v of 2 minus 2. So you're going to take your answer and add 2 to it. So that's your answer, except you have to do it. Calculator problem. Mm-hmm. But they expect you to do it this way, and they'll look for it.
Not on the multiple choice.
No, not in the multiple choice. But that will. This is not in a non-calculator problem.
Yeah.
Probably have time for one more problem. Or no, maybe not. I do believe they are online. I know some more of these are online.